Okay, fantastic. Let's begin. My name is Yuri. I'm VP of Engineering at Diligent, and today we are going to talk about 10x engineering, unleashing the power of innovation. Little bit about myself. I'm more than 20 years. I have more than 20 years of experience as engineer. I have 12 years, a little bit more than 12 years as a manager. I do participate in many projects as software architect. Right now, I'm running probably biggest transformation project in my life. It's transformation project of Diligent. We transform almost everything and modernize all our application, and we have a lot of different applications and a lot of heritage software, legacy software, and some new fashion stuff. And hopefully in several years we will build amazing new platform of the future for GRC. I really focus on efficiency. It means like everything that I'm doing, I'm trying to achieve efficiency in processes. It might be some kind of process related to how we, for example, manage our task. It might be some process related to provisioning of infrastructure. Almost all processes I really like polishing, and I'm paying always like attention to small details. Also, I'm multi-stack software engineers. It means like I have experience like mobile engineering. I have experience like definitely full stack. I do have some experience related to machine learning and AI, and yeah, almost all new technology that appear like get my attention usually. I didn't have a chance to play with VR for iOS, but it's in my list. Let's go back to the topic. It's how everything began. Everything began in 2019, and it was very hot topic. Immediately, like it appeared like in many articles in Twitter. It became part of Twitter trends. Like almost all engineers get involved, but it's quite fast became a meme. And it was like transition to a very controversial topic, because many articles that appeared these days, like they're mentioned like, hey, kind of only I am 10x engineer, I know how to do that, and like you need to learn from me. And many people start doing the same, and of course everyone else start creating a lot of different memes. And this is one example of this meme. It means like, okay, what if 10x engineers are actually kind of in binary system 10x, and it means like they just like 2x engineers. And it was a lot of different jokes, and you can find like 10x engineers meme, and you will find a lot of different pictures, like a lot of like fun stuff. What is this talk not about? This talk is not about how to typing 10x faster, because like if you really want to get this skill, it's still really cool skill. You can get some software, like you can get some like application and try to type 10 times faster. It's not about writing 10 times more code. And it's not about like working 10 times more, because it would be obvious you would be like 10x engineer. We are trying to talk about like how to live your normal life, but at the same time achieve more as engineer. And why we are talking today about this stuff? First of all, this year definitely like it's year of AI. Like you can hear like everywhere, like you can see like news, like you can read articles, like you can read magazines, and everything is about AI. It's about ChatGPT. It's about like transformation. It's about like how to boost performance. It's about knowledge democratization, and knowledge democratization means a lot, because it means like we already became like species that always have Google, but at the same time Google not always provide like very detailed like information, and doesn't explain everything in details. Right now you can do it like as a chat, just one message. Like for example, during this talk, like if I have question, I can just send my prompt to ChatGPT and get like very comprehensive response on some topic, and it's very, very like transformational for many different industries. It's productivity area, and I would say it's boosting some productivity like 2-5 times. Many industry, for example, like writers of articles, journalists, like just imagine how they became more efficient. But the same, it's about engineering. Engineering also became totally different. Despite like I noticed for myself, for example, I still didn't get this habit. I still follow many different rules, but still moving much faster than it used to be. Okay, what is direction for like performance boost? Performance will grow, and moreover, like everyone can be 10x in engineering or any other like profession. And the most important that I would like to mention about this talk, that actually AI is just small boost for everything. And I brought this example. Why, like I called this slide 10x, 100x productivity. Why 100x productivity? Because it's just part of chart. Actually, if you get like whole statistics about like human civilization, you will see that our performance grow like 1,000 times. It's not even 100 times. It's about 1,000 times. And just to consider like what's happening. Like this chart begins in 1947, and if you take, for example, like for 6 years period, you will see that actually performance grows like 20%. It's something that like many people experience with ChatGPT, with Copilot. This is performance boost that you can achieve by just regular improvement in the industry. Moreover, like if you start thinking about like this period of time, that approach to do things was totally different. It was in industrial economics. Right now we live in post-industrial world, and it's totally changed. Everything is totally changed. Like your performance might grow much faster, and your efficiency might grow much faster. The most important is that we constantly improve our performance, and it's just natural process. Also, I would like to mention that no one born as 10x engineer, and the most important, how to transition to this 10x engineering, to start thinking differently. Always challenge yourself, challenge people around you, and challenge like even managers, challenge product team, challenge problems that you are trying to solve, because it's how you can boost your efficiency, and it's how you can achieve more. And of course, 10x, it's about polishing mastery. As soon as you start thinking differently, as soon as you get new habits, you need to polish it until you satisfy it. Any questions? Any comments? All good?
Just
Yeah,
one quick question,
sure.
if I may. For the 10x, to think differently and mastery and whatnot. I know AI is pretty close or pretty new to this I guess just the past 10 months or so. How might the use of AI be affecting how engineers are working?
Like we need to change habits related to AI. But as I mentioned, AI is a just small boost, and the most important everything outside of AI, everything that like we had for many years, everything like as this industry began, and it's exactly about thinking differently, and we will continue. And like I will cover these details. We can get back to your question at the end of the presentation. Is it good?
I have a question.
Sure.
What is so special about 10x, or are you just saying it's a big improvement, or is the number 10 of any significance? Thank you.
10x means like very big improvement. Because for example, like 20%, like you can achieve easily 20% boost. Because like 20% boost, you can start overtiming and you achieve like 20% boost. It's doable, but it's impossible to achieve 10x boost, because like just imagine like regular working out like a day, like for many people, like eight hours. And what means like 10x boost? Like working like 80 hours per day? It's impossible. Writing 10 times more code? It's impossible. The most important about 10x, it's totally different level of outcome that you can produce for customer during the same amount of hours.
Thank you.
Okay, let's go to the next slide. Patterns. Like I would like to start talking about 10x from probably points that I noticed during my career. It was like many years ago, and I start learning and another technology. It used to be like super cool, sexy technology. It was iOS development by using Objective-C, and I noticed the big difference, and I couldn't explain these days. But after that, like during many years, like I was thinking, my first experience, like my first like commercial language that I used for my career, it was C#, it was .NET, and I learned a lot of examples like from Microsoft, from MSDN. Like you can navigate. It's like huge library with a lot of examples, and I started learning iOS development. Apple didn't have such great examples as Microsoft, and I should learn from articles, like some kind of like small examples. It went very like complicated, but the most important that we get habits from these patterns. As soon as we start learning languages, like we get habits, and sometimes we get habits that don't fit very well in real world. For example, like if we are talking about C#, during these days, like it was like C# .NET 2.0, just to read like simple config file, custom config files that you would like to implement like in your application, you will like you should implement like 3-4 different classes. Of course, like probably write some tests for all of this stuff. It means like create a lot of source code with very questionable value. You would like to get custom section in your configuration file for your application, just to say, for example, yes, no, false, 1, 2, 3, like just to pass parameters to your application. And like usually it took like 1-2 days. Today, many languages that we use don't have this habit. They have totally different behavior. If you want to read config, just read JSON, and you get like your configuration. Just read environment variables. It's how industry transitioned during this time. We became significantly more productive for the same operation. The same I would like to mention about iOS. And for iOS, I learned from other developers when I was trying to explain to us developers how to write software better, how to not duplicate source code. Because if you go back in these days, iOS examples were like all of them, they had controllers and they had almost everything inside controller. They didn't have any level of abstraction in in application. You need to get HTTP request, like you create, you form like very complicated request, you send, and many engineers start copying these patterns in commercial application, and it create like hell. People start producing a lot of source code. People start producing like a lot of complexity, and at the same time, when you need to change something, like you need to go and change like 20 times. And of course, these patterns, if you learn there is a pattern and you can optimize this pattern, you can become significantly more efficient as software engineer. For example, if you would like to implement download, let's create file, let's create a layer for download in iOS. Right now, it looks like quite common, probably like all of us we are doing, but industry was not there, and we constantly improve. And right now, we're still not there. Like many things that we implement will be ridiculous in 10 years. But we can start rethinking all of this stuff today. We can start asking why we are doing all of this stuff, because like from all of these questions, like it looks like simple question, innovation starts. It means like very often I get some questions like from like a different level of engineers, sometimes like from junior software engineers who just like recent grads, and they join, they start asking, and you realize like, yeah, right, I'm doing something very silly. Probably I can be significantly more efficient. Let's improve it. And you learn from this type of communication. You learning from thinking differently, because like these people fresh for the industry and they have totally different understanding of the world, and they asking right questions. Let's talk about less code, how industry actually progress, like because as I mentioned, like there are some stuff related to like C# and iOS that was like changed through the years, but at the same time you can see transition of whole industry. We get a lot of new languages during last 5 years, but all of them it's not OOP. They don't have even classes. Some of them have structures, some of them have a little different approach, but not classes. It means like we see that like classes and OOP, it's kind of it's not necessary for modern software engineering. And moreover, like if we are talking about like C# as example, in C# in Microsoft culture, it was such kind of approach, like you need to create class that does, for example, some operation with like with files, and you create a factory, you create abstraction, you create just for simple, very simple task, move file or like read file. It's very complicated approach. It's very heavy approach. And right now, languages by itself trying to prevent, don't do that. Try to make it simple. Moreover, like I just recently installed the latest version of Visual Studio, start working on some project, like work-related project. And I just realized that there is a new version of .NET that actually don't have wrapping. It means like right now you create like modern .NET application and you start writing your application. You don't need to write all of this class, program, main, whatever. Like you don't need even write using. You just start developing with significantly less code. You can get efficiency with less code. Write less code, and yeah, actually this slide is, yeah, I lost some industry changing. Yeah, but in general, industry changing, and we became more efficient only related to that. And if you're still using, for example, C#, if you're using, I know that many people still using C#, Java, like try to rethink all of this stuff. Try to rethink approach, like how how you create classes, how you create abstraction. Do you really need this abstraction just to write less code? And again, sometimes like you can kind of, like for example, Python and TypeScript, it's tooling. You still can get all of these habits by using Python. You can create a lot of different classes and abstraction. You can create a lot of different classes and abstraction with TypeScript. But do you really need it? Probably no. Probably you need to focus on reducing source code. Any questions? Comments?
You can just comment. I mean, I totally agree with this because I see, for myself personally, that reducing the amount of code actually allows you to move faster, make changes faster, develop faster, and just, that is in general pretty good thing.
Thank you, Mike. It's why we are working together.
Yeah, that's true.
Hey, Yuri, I have a question. So let's say you find yourself in an organization that continues to use a lot of these, OOP practices and, continues to believe that the best way to engineer uses a lot of these practices that often create more code rather than less code. How would you as a transformational leader approach that problem?
It's very complicated problem, Greg, amazing question. Because just imagine world is living its own life and you appear as a Batman, as a Superman, and you're trying to explain to whole world that actually all colors, what they see totally different. And moreover, it's inversion. If you see white, it's black. If you see black, it's white. And a lot of different variants, and what you're going to experience, people won't believe to you because they used to work for many years, for 10 years, for 20 years, many for even more years, and use it with patterns. It's the same as to explain, for example, to people right now, to all educated people, that the earth is flat. It's kind of the same approach. You need to understand it's very complicated process. You need to understand that people won't believe you, and moreover, you will get always resistance. But when you feel this resistance, you're on the right way. If you're talking about transformation goes only from by resistance. And personally for myself, I choose such strategy when I'm trying to explain to something and people are not ready. People say, no, we are not going to change it. I just stop and wait half a year. And when it's a good moment, for example, something happens in half a year, and there is a very good moment to mention that, do you remember I mentioned it might be really good opportunity just to get back to this topic. I always trying to get back to this topic. And to be honest, all of these topics actually very limited. It's not just huge list of different topics that I would like to discuss. It's constantly the same topics, and you going over and over again, and you're improving related to these topics. But it's a journey. It's a big journey, and of course, some private conversation might help, because if you get someone who for example, new grads. If you have new grad and you can explain something, and they will get to your idea much faster, because they didn't have these habits, and they might be agent of changes. They might explain together with you. And I remember when you joined our company where we worked together, and many people said he's amazing, he actually thinks differently than he show all of this stuff. I've heard from our coworkers about you, and it's how it works. Find Greg. Greg, find Greg. It's solution. Yeah. Okay, any other questions? If no, let's continue. 10x more time. I already mentioned about wrong abstraction. Wrong abstraction is time killer. You can create abstraction for everything, absolutely everything. You can take simple problem and make as many layers of abstraction as you want. And I saw it in source code, and all of these like applications are like not stable. People unhappy. It's usually very complicated. And I saw significantly totally different project without any type of abstraction. You need copy file, just copy file, one line. And people were significantly more happy. Stakeholders were significantly more happy about this project. But at the same time, for example, like you need to understand the reason, because like when people create all of this abstraction, they not created just like for kind of for current moment. They create it for the future, because like what if in the future we are going to change like storage and we need to copy file in a totally different way? What if we change operation system? What if we change, I don't know, like almost everything, and people trying to predict what they will need to change? But like, okay, let's go back in time. Let's go back in September 2022 and try to predict what's going to happen next couple months. Try to predict that actually ChatGPT will become the most popular application. Moreover, like this application get million users during like first 5 days. No one would say so. And it means we don't know future. And all of this abstraction is just like our imagination. We imagine that world is going to move into this direction, but we actually don't know. It's like, it's the same as like market. It's the same as stock market. You never know direction. And even like if you're like super expert in the industry, you don't know direction, what's going to change in software industry during the next 10 years. Don't make wrong abstractions. Don't dry architecture, like don't dry approach. Dry, it means like do not repeat yourself. People trying to solve problem again and again and again and again. And right now, like all of us, like we are sitting and say like, probably like I know what he's talking about. Probably he's talking about very valuable stuff. And I saw it a lot in our source code, but not only like I never do that. Probably someone else, but I really want to challenge this idea today. And let's just take a look and be very honest to yourself. Let's take any type of application. You will see this, like especially backend application, like you will see the same approach. We create Nginx, like gateway, any type of gateway. We create application, API. We have database, and we constantly repeat this cycle over and over again. It means like for many backend application developers, like people who develop backend, it's kind of almost the same task. You need to create new method. You need to create put, post, delete. And it's over and over again for different type of items. But in general, like approach is absolutely the same. And you need to think about like what we can do significantly more efficient in this cycle, how it might be simplified. Can we solve this problem once? Can we create something that will read all different type of items from database? And there are some solutions for that on the market. Don't get me wrong, like it's already exist, but you need to ask this question, because like innovation and tenets starts from thinking differently. It's just example, thinking a little bit differently. And sometimes your colleagues might say like, no, it's crazy idea. We don't have to do that. But let's try. It might be like your pet project. It might be some experiment, but you will definitely learn from it. 10x more time using inefficient technology. It's very fantastic, but like in software engineering, like very often we use inefficient technology. And it might happen for many different reasons. It might happen because we don't want to learn new technology, and we would like to use like very familiar, for example, like C# and .NET 2.0, like everyone knows, and let's continue using it. Why we need to make experiment? Because experiment is risk. in many cases, we are using an efficient technology for this particular problem. And with .NET in particular, like it has amazing advantages, but it has disadvantages. And in some particular cases, it stopped working. It stopped working, for example, on high load. When you create like huge load on container, and it's not enough resources just to release memory in application. Garbage collector don't have enough time just to release memory. You might get fantastic performance, but after that, like performance drops and your customers start to experience a lot of trouble. For some cases, it works very well. For some cases, it doesn't work very well. And you need to understand what is your case, what technology you need to use. Should you change your technology and stop experiencing this problem? Because, for example, many people get to this problem, like this garbage collector, and start solving it, create workarounds, create like some kind of delays just to allocate time for CPU to release this memory. All of this stuff is possible, but it's not very efficient. It's complicated workarounds that engineers implement in their flow, in their source code. And you're already working not on something fantastic that like you definitely came today to work. You start working on something that just work around, just like cutting some corner cases and try to make it work. Any questions?
I
have a
want to ask.
question.
Just a
Sorry. Yeah, sorry. Go ahead.
Yeah, sorry. Actually, I wanted to ask, what do you think about the serverless apps like, DynamoDB and so on?
Serverless is fantastic, but for some particular cases, if you're working with enterprise, you don't have too many requests. Serverless is good. If you have B2C, serverless is not good. Couple years ago, I made presentation about serverless for this Meetup group. We have recordings in our on our YouTube channel. You can take a look if you're interested what I think about serverless. And yeah, serverless is good for some particular cases, but not for all of them.
Thank you.
Mike, you wanted to ask something?
Yeah. I was going to ask the question about the complicated workarounds. So, like, would you say that every time where you're like when you're finding yourself doing complicated workaround, it means that you're just doing something wrong, and you just need to change the direction?
Or someone else made something wrong because I don't want to mention some names of products from some cloud providers, but you totally understand that there might be some better solution and there might be something fixed on their side, and you need to do these workarounds because you're using proprietary solution, for example, that you don't have any type of control, but you need to solve your particular problem for your particular customer who is paying money to you. But in most of cases, it's a signal for your brand.
Yeah.
You're doing
Okay.
something.
Yeah, I see. Cool.
I have a question about the last point in the previous slide. Yes, thank you. So for complicated workarounds, I was recently in a very similar situation where I realized that something isn't being done in the right way, and my task has to do with something in that area of the code. And refactoring and doing it the right way would take at least a few days. And so my question is, if you're in a situation like this and you're expected to deliver, let's say in X number of days, but you're in this situation where you can choose to deliver late, be late on delivering your task, but do it properly, or just use the existing complicated workaround and just deliver it because customers are waiting for it. So what would you do in this kind of situation?
Again, it depends who customer are, because for example, if customers and what type of software we create, because for example, if we create software for kind of hard, For example, like some kind of micro.
No, it's a SaaS, and let's say the stakeholders are upper management.
In this case, I would try to explain, especially if it's internal for internal usage, upper management of any company, or like your own company, like your company.
Your own company, and assume that upper management tells you, no, we can't wait. And not only that, but you get a similar task the week after, and the same problem reoccurs over and over, where you're technically forced to use a workaround instead of solving the actual problem.
You know, I can explain my flow of doing things, but my flow, it doesn't mean it's right flow. It in many cases, like I suffer from this flow, to be honest. And this flow is like, you know, like I really think it should be done. Like you need to do it. You must. It's kind of like I really strictly connected to this like approach of to have source code in much better state than you get it when you open this file. I am always doing this stuff, and I would try to negotiate with management, but if they push back, I would sit and do it like over time. It's kind of my approach, and it's very bad approach. I know, like it's very bad approach for like work-life balance, but it's how I do that. But I would try to do everything just to negotiate with management. Again, it might be an option like that I would postpone, but at the same time I would get it into the list and fix it a little bit later. As soon as we release, deliver value for customers, and after that, like I would try to negotiate, like, okay, we delivered, like let me try fix. But moreover, like in all of this stuff, like you can bring economics, you can bring ROI, because like, you know, in many cases you're trying to fix something that cost very expensive, and many engineers will pay, many generation of engineers might pay. You're trying to simplify. There is economics behind all of this stuff, and simplicity, it's not only like kind of something not tangible. It's very tangible. And management in many cases, like they kind of first people who should say like, hey, let's go, let's fix it, let's make it perfectly fine. I really want this feature to be polished as better as possible.
Thanks, appreciate the answer.
Sure. And number one, it's a point that I would like you to get from this presentation, and because of that, please pay attention to all of these points. And number one, the best code is no code. Don't create source code. Like we spend huge amount of energy to read this source code. Like we have huge amount of energy to fix vulnerabilities in this source code, fix bugs in all of this source code, write tests. The best code is no code. It's kind of your mantra just to get to first step related to 10x engineering. Next chapter, and this chapter about us, about humans. It's about what we got from nature, and we got from nature something that like many companies, like large companies, social networks are using. And you get like on social network and you get more dopamine. You definitely get like much better feeling. You get notification and you get sense of urgency. Something happens that I definitely need to read. I definitely need to read, and I definitely need to know this stuff. It's very important. And all of these notifications, all of these likes happens during your work. And it happens not only as social media, it's not happens as notification from your news application, it happens in many different cases. For example, refactoring. Refactoring, let's do it better, let's do it now. It's topics that we discussed. We just discussed it. You get definitely dopamine from it. And very often you start doing this refactoring, but different cases, absolutely different cases. Or for example, you realize that your peer has a question and you would like to help your peer just to solve some problem. Let's do that. Why not? Or working on a very urgent task when your boss coming to you and asking about like, you only one person who can save this world and work on this urgent task. And you always get dopamine, always from it. And it's very important to remember. And this urgent task, this help to your peer should be classified, because you definitely need to understand, classify this task, you need to understand outcome from this task. Is it urgent and important? If so, do this task. If your peer asking about help and this task urgent and important for your company, not for your peer, let's do that. If it's not urgent but important, let's schedule. Let's schedule, allocate some time, but do not jump in on it immediately. If it's not important at all, but urgent, try to delegate, try to find someone who can work on this task. You have a lot of peers, try to negotiate. And if it's not urgent and it's not important, don't do this task at all. And this is Eisenhower matrix. It's a matrix that used Eisenhower, like who was like president of the United States, like for just daily routine every day, just to become more efficient. And my amazing coworker Mike B, like we just like half a year, like or a year ago, like we used this approach almost every day, because like we understood we have a lot of source of this task, and we need to classify and work only on urgent and important. Otherwise, we don't have any chance to be successful. And it, like, you will see how it transition, how it change your workday. I brought this example like from Asana. I'm not sure about like Asana. I never use Asana's product, but I always miss all of this stuff, because like all my life I'm using Jira, not because I want, because I need. And Jira doesn't have this view. When you're working on task, you cannot separate. Is it important? Is it urgent? It's impossible to configure it properly with all of even filtering. It's very challenging stuff. But in general, like, you will see that you will be significantly more efficient related to your time management, and you will finish 10 times more important task. Any questions? All good?
Yeah, just a comment about that. Like, just to mention that people may not like realize how much distraction they get like during like every day during work, because there are like so many sources of distraction. Like people writing in Slack, there are some incidents happen like on production, incidents happen on non-production, like something else is going on, and like all this, like it may be 5 minutes, like 10 minutes kind of time needed for every such task, but it sums up, and you just spend your whole day working on non-important stuff. That was like one of the big problems for me, because I was easily distracted and just like
like
wasting time on like non-important stuff. It is urgent, but it is not important, and it is like very hard to manage without this kind of view.
Actually, it's very easy to distract him. Like we like you can try. Like if you're working with us in the same company, you can message like, Mike, could you help me, and just send your task to Mike, and he will like resolve it in 20 minutes, and like
yeah, that's the problem. That's the problem.
Okay, let's move. And the second thing that I would like you to remember from this talk: work on important task. Okay, one more meme. And I'm pretty sure like you saw these pictures, and it's very famous video. I remember when I first time saw all of this stuff, and I just realized it because when you're watching such videos, like you realize, oh, exactly, like I know what you mean. I know what you mean. Client is trying to get something. Business analyst trying to kind of digest all of the stuff, get something totally different, and developers produce something that barely works. And usually, like it's in your brain. Like I know what you talking about. I know it happened in the past, or like it happens right now. Like all of us, we have a lot of such examples when it happens. And like for some companies, it happens over and over and over again. It means you constantly see the same pattern. Like client wants one thing, and developers produce totally different thing. Source code that doesn't work, like has a lot of bugs and barely usable. And it's about expectations. It's quite common problem for many different companies on different size. Like for large enterprises, like for small startups, it's very expensive. You need to understand that like it means like we have cycle to deliver something, and like we might waste whole cycle. We can do something that our customer don't need at all, and we might have mistake on some initial stage, on requirements, on like even like like in some beginning, even like some like a client might by itself to describe problem from his standpoint of view without holistic understanding of technology world, and it might be misleading us to create all of these documents. And the main point of it that you need to understand, you need to focus on outcome, and outcome here on this slide is what really customer want to get. This is outcome. But this is kind of also outcome. I mean, it's not outcome, it's output, to be honest, because developers is focusing on something that they need to produce. Because if your even output first time was not what customer needs to get, like you need to design your flow, you need to design your flow just to fix it, just to understand it's not what our customer want to get. Let's fix it. Let's have another iteration. Let's try to get rid of all unnecessary step and get this picture what customer want to get. Yeah, as I mentioned, don't focus on output, because in many cases we focus on output, and software engineers like on different level, like in different companies, they understand their role a little bit differently. It means, for example, like someone should create a task for myself, and I need to work on this task just to like, for example, until like task open to code review, and after that someone else will care about this task. But it's output. It means like you focus your life on output. Like I'm kind of machine, I'm working, like I'm producing some output. It doesn't matter quality. As soon as you start adding like some quality assurance, different type of quality assurance by internal teams, by external team, by customer support, and start getting feedback about like what you produced, you will slightly start transitioning to outcome. It means like more something that like your customer would like to get. And you need to understand your customer eventually, like, because the main goal of this exercise, like build understanding of customer. And when you start working into this direction, you get a lot of different questions. For example, domain knowledge. I'm working in a very interesting domain. This domain is called GRC, governance, risk, and compliance. When I joined company in 2019, at the same time that tenets engineering appeared, I didn't know anything about risk at all. And since then, since the moment as I joined company until today, I'm constantly going through some courses about risk, about governance, about compliance. I'm trying to understand what means cybersecurity. And I am trying to understand what is points of what is the pain for our customer. And it helps me to grow. Because if you start talking about almost any domain, you will see there are a lot of gaps. We are not domain professionals. We are software engineers in many cases. We are just software engineers, and we don't understand. We don't have this knowledge. We didn't get this education. And if you want to produce outcome, you need to understand what they really need, what they really want, what is the problem. And for all of this stuff, you need to get knowledge. Today, again, you have knowledge democratization. You can use ChatGPT, you can use like Coursera, you can use whatever you want just to get this knowledge. But this knowledge is kind of important for outcome. You need to understand customer problem very, very deeply just to solve this problem. Without understanding customer problem, you won't be able to resolve. And what I really want to mention, sometimes conditions that you get in your task, it's already missing some key points, because some people who interviewed also don't have domain knowledge, also didn't get this education, domain specific education. For your like particular domain, it might be like totally different stuff, but in many cases, like your task might be already misleading. And because of that, like you need to try to change almost everything. You need to try to rethink and ask question, why we are doing this stuff, just to get fully understanding. You need to understand value for customer, because sometimes customer want, but value almost zero. And it's also very important to understand, because this stuff helps you to make proper priority. Because some task might need to be done first, and it produces significantly more outcome for customer, because it has significantly more value. And some task has less value. Without understanding what exactly value, it's very complicated to make prioritization. Any questions? All good? Fantastic. And third point that I would like you to remember about this presentation, focus on outcome, not output. It means like not on your task, what you changed for customer, what you changed, how customers' life became much easier after your release. Okay, it's about 10x approach. You always need to analyze different approaches, because when you fully understand outcome, you might achieve this outcome in totally different ways, absolutely different ways. And your approach to choosing right one should be minimizing your efforts and maximizing impact. Like for this purpose, I would like to introduce framework that exists like for a long time. It's almost like 10 years, a little bit more than 10 years, like 11 years. It's called impact mapping. And many product managers use this framework. Why they use this framework? Because this framework helps you to minimize the amount of efforts that you spend for your deliverable. It means, for example, you have some goal. For example, like we would like that our customers know about our application, and you have different actors. You can, for example, work on software engineers, with software engineers to add some meta tags in your application. It might be some impact, it might be some deliverable that they introduce. It might be, for example, implement posting to social media, again, software engineers. Or you can even buy advertisement. Like you can, for example, use Facebook ads just to get your customer. It also might be option just to achieve this goal. And very often, advertisement might be cheaper than software development. And you will get significantly more outcome. It means like your ROI will be much higher. It's how it works. And the same you can apply for software development for your day-to-day task. As I mentioned, it works for product management, and you can apply for a task. For example, I want to bring example. Just imagine we got a problem on production. Our database became very, very slow. And we have a lot of different options. Provision more CPU, provision more memory, provision more IOPS, optimize some queries by team, hire expert. And when we make decision, we need to understand what we need to do just to achieve this goal. Because worst thing to get database slow and no one knows what to do. Let's create this different option. Let's consider different option. And let's try to think about like cost. Let's think about like, for example, like, can we provision CPU? Will it help for this particular problem? Do we understand problem? Do we understand how to solve it and how much is going to cost? If yes, CPU cost, it might be an option. If we see, for example, like we have very high memory utilization, CPU might not help us because we need to provision more memory, and memory has totally different cost. And again, in many cases, like I made presentation about databases, like in many cases, like your main problem is IOPS, and you need to provision IOPS, and sometimes IOPS much cheaper than CPU and memory, and will have significantly more outcome. And your like CPU and memory utilization for database is a result of low throughput when database is trying to optimize all of this stuff by itself. And another option, spend huge amount of time, train team on indexing, or even hiring expert that significantly more expensive. And you can understand what works for your particular case, what you would like to implement, and what will be cheaper for you, cheaper, efficiently, faster, just to achieve your goal. When you understand, when you draw all of these three, and you understand your deliverable, what you need to deliver, how much it costs, you will choose options that will cost 10 times less. You will choose options that will take 10 times less to implement. Also, I would like to mention, when you're trying to optimize impact, you need to understand tooling that you're using. Because sometimes people trying to make impact without deep understanding of tooling and limitations of this tooling, because limitation of this tooling is also very important. You need to read, you need to understand. In this case, like, you will be significantly more efficient. You don't need to create this workaround, because if you don't know limits, it's going to definitely will be workaround. Remember that all computer system, it's not something non-tangible. All computer system have very tangible thing, and this thing built on top of physics. Physics exists. You cannot transfer information between data centers in a second. You will have delay. It's physics. It's how it works. You still need to understand that a HDD might be limited. You need to understand all of this stuff, and of course, like, you need to remember about combinatorics, because in case of software development, combinatorics very often the solution. It means like sometimes we come up with solutions that creates like n factorial variants, and you need to understand that it's very complicated. Any questions?
Sorry, I wanted to get it more clear for me. IOPS, it means like input-output operations.
Yes.
Okay, thank you.
All good? Okay, maximize impact with minimizing efforts. It's point number 4 that I would like to remember from this presentation. And the last, we finally get to AI. Today, AI is almost everywhere. ChatGPT, Copilot, everyone is using this stuff. And it's going to become simply more proficient. It's going to boost our performance more. But you need to understand, it never probably will be autopilot, and it never will be like 10x. It's going to be like 20, 40, like up to like 2x. If it will be 2x, it's going to be fantastic. And many optimizations that you do with AI, you you trigger it. You need to start using agent. If you don't ask ChatGPT, its approach of Copilot, if you don't ask question, it won't produce outcome. And everything depends on your question. And in many cases, you don't know what you don't know. In many cases, you ask wrong question and you get wrong result. Because all of these like 4 points that I mentioned, it's prerequisite to start using AI more efficiently, significantly more efficiently. Because AI, it's like cherry on your cake. It will make it much better and significantly more efficient, but you need to have all of these prerequisites, because you can ask question that will get you to rabbit hole, and AI will produce you such answer so that you will get to rabbit hole and won't be able to find your solution. You need to understand all this concept. First of all, you need to understand concept being Copilot, not autopilot. And we were talking about knowledge democratization, and we were talking about domain expertise. And when we start talking about AI, first of all, we start talking about like, hey guys, right now we start writing source code much better. But as we already understood during our presentations, it's significantly more efficient if people know domain knowledge. And you need to understand that software industry during next several years is going to transition. And it's going to transition in directions that right now software engineer will be domain experts. And you will get significantly more people who transition from, for example, like you're working in financial company, like people who work at financial departments start transitioning to software engineering because they domain experts, they know what to do, they know about all of this process, and sometimes it's complicated to explain to you what they need to get. And moreover, like I just like last week, I had several conversations with our customer support team, and it looks like if you provide proper tooling for them, they can solve it. Like if you provide like very advanced version of Copilot, they will be able to write this source code much better, significantly more efficient than software engineers. And the most important, to solve this problem for customers, significantly more efficient. And it's a point, like you need to understand AI has totally different side for people who get education as software engineers, who became software engineers because they like how to develop software. It means it is going to be trend. It's going to be very, very like popular trend, and it's going to be grow. And point number 5, domain knowledge is very important. You need to understand if you're working in some domain. I highly recommend you to learn it in depth. I highly recommend you to talk to these people who already know this domain, just to become domain experts, because it's going to be like power during next decade in software engineering, domain knowledge like will rule almost everything. It's 5 points from my presentation. Believe in yourself, success is inevitable. Thank you for joining. Any questions?
Sorry, where can I find the link to your YouTube video that you mentioned before, like about the serverless? Maybe you can, or somebody can share it in
Mike,
chat.
could you share in chat link to our YouTube channel?
Yeah, for sure.
Yeah, thank you so much.
I just want to point out to everyone what Yuri did there. That was an example of that Eisenhower matrix, right? He had a task to do that was important but not urgent, and so he did delegate it over to Mike.
Thank you so much. Yeah. Any other questions? If no questions, you will get 9 minutes back, 8 minutes back. Thank you for joining. It was amazing to see all of you. Many of you joining like many times. Yeah, I'm absolutely happy to see all of you, and feel free to join next time. It is going to be October 25th at 5:30, as always, online.
Yeah, I posted the link in the channel in the chat just in case.
Yeah, thank you. I wanted to say thanks for this presentation, and it was interesting to take part in. So thank you very much. I really appreciate it.
Yeah, join next time. Thank you.
I will.
Thank you.
With pleasure.
Yeah.
Thank you.
Yeah.
Thank you.
Thank you, everyone.